for my Regents students, if they have questions before I get into all the ins and out of the AP exam. And then AP students, I will share everything I know. Chances are I repeat, cannot answer any questions because I have no idea. But I will go over exactly what was shared. And then I will go over this entire unit in its entirety. That was repetitive, but that's fine. Do like a big review thing. So again, let me give a minute for any Regents students that might have questions. And then AP students, I'll go over everything that they just released. Some of you already looked at it. Some of you already texted me and remind about it. But I'll go over what I can. How's everyone doing today? Good day? It looks like the weather's been holding up a little bit. Not as much rain as I thought we were going to get. And I'm waiting for it to get warmer because we were promised 70. I'm not feeling 70 yet. So, still says on my phone, high of 72. I don't know about that, but we'll find out. So chat's open. Remind is also open. AP kids, I'm going to go over everything that was just kind of like released by College Board and do my best to answer all of them. But I probably won't be able to answer any of them. So, Regent students, any questions? Anything? All right. Get more people coming in. How we doing? How's everyone's day going? Hello, everyone. Getting more and more packed, I see. Again, I'm just going to hold off on the AP stuff. AP students, I plan on going over everything that was just kind of released by the College Board. They're doing clarifications like on Twitter right now. So I'm trying to like pick things up that they're putting down there. But I will do my best to answer any questions. No guarantees I'll be able to answer any of them. But Regent students, do you have any questions on what you should be doing, where to find material, tech support, whatever? Just text me on Remind. AP students, hold off for a quick sec. All right. I'm going to go straight into the AP stuff because I'm not getting any love from my Regent students. So, let me share my screen here. Take you, put you. So, information for AP students affected by the coronavirus. Let me just make sure this is popping up. I think it is. I'm like looking at my channel right now just to make sure it popped up there. Okay. So, I'm just going to go through this and I'm going to cover AP exams first, and then I'll go over what New York State released about state testing. As of right now, actually, let's just say that right now. They have not said anything about high school level Regents exams. So any math Regents, science Regents, any high school level Regents exam, they have made no decision about as of today. They did have a press conference today where they canceled like a lot of grades 3 through 8 exams. So they made some announcements about that, but the Regents exams as of right now are still a go. If you have siblings in 8th grade that are accelerated and they're in like Algebra 1 or Living Environment, that's a high school level Regents exam, and that, like I said, is still, as of today, scheduled as is in June. So they have made no announcement about Regents exams. They canceled a lot of grades 3 through 8 testing, but again, they made no announcement about Regents exams. All right, AP. So, first thing to take note, it's clear that the usual way AP exams are given at schools won't be possible. They are not canceling AP exams. Let's say that right now. Not canceling them. Their plan is to offer 2 different testing dates. We do not know what those testing dates are yet, so I cannot answer that question. But the plan is they want to offer one sometime earlier, which makes sense. One is inevitably going to be earlier than the other. The logic behind that is they know some students just want to get it over with while the content is fresh before they take off too much time from school, etc., and then another test sometime after that first one. Again, there's already some confusion about this. The dates, full exam schedule, specific free response question types, etc. will not be announced until or on April 3rd. So sometime by April 3rd, they will make the announcement about when each test is and the general format of each test. But as of right now, we do not know when they will be. Okay? So April 3rd is not the day of the test. No. It is when, that is the deadline they've given to themselves about when they will release more information. According to this, they surveyed 18,000 AP students about wanting to opportunity the tests this year. From what they've told teachers, 91% said yes. I do not know who was given this survey. Do not ask. I did not hear anything about that survey. They will be giving free resources to help you prepare. So what they're doing is preparing a 45-minute test. So it was originally a 3-hour test, or something around the time limit, is now going to be 45 minutes, and according to them, will be free response only. Now, I'm going to take this opportunity to let you all know, before you make any decisions, that College Board is notorious for going back and changing their minds on things, and I can already say now that what they told teachers was they were developing a 45-minute test. And again, what they've told teachers is what they told us today, was a 45-minute test, and they gave no specificity if it would be multiple choice or free response. And then at the same time, they're telling you guys that it's exclusively free response. So will this hold true? Most likely, but I wouldn't put it past them to change their minds. So as of today, I don't want to bookmark it. It's a 45-minute test, all free response. It will focus on what most schools were able to complete by early March. Now, this is already also causing some issues because the College Board releases their own scheduled timeline. Like, you should cover X topic now and then move on to the next one. But they also say, we understand that local districts can develop their own curriculum and we fully support your decision to go in whatever order you want. So, I don't know how they're going to come to a decision about what units they want to test. We have a general idea of what units. We have covered all of those units already, so we should be okay. But I would hold off on getting your hopes up that we don't need to learn new stuff because, again, people are already raising their hands and saying, well, excuse me, you said we could go in any order we want. If you decide the order that the test will be, then that throws off everything that we've done with our students. And I've even seen one, like the AP government teachers, they go in a certain order to make sure they cover election-relevant material in the fall, though the College Board's, quote, suggested order has that coming later in the year. It also brings up kind of an equity issue as some states start school in August, so they can get further into the curriculum than states like us that start school after Labor Day. So I'm safe. What I can tell you is that I'm very certain whatever decision they make, we have covered everything so far. But I don't want to say that we shouldn't move on and learn the new units because who knows what the final decision will be. But I will be talking to Mrs. Bell about that and getting more details. It says you'll be able to take your exam on any device, computer, tablet, or smartphone, and you'll have the option to write your responses by hand and submit a photo. Testing security, great question, no idea. Colleges support this solution. Who knows how many colleges they've contacted, but they're insisting that they support it. We know not all students have access to the internet or a device, or I should even say, as we've experienced so far this week, a reliable device. That's part of the problem-solving aspect that they will have to answer. The person in charge of he's the vice president of advanced placement, has also said, just to confirm, the at-home AP exams this year will not include any multiple choice questions, only free response questions adapted for secure testing at home. So I find that to be an interesting statement. Adapted for secure testing at home. I don't know what those look like. I'm hopeful that they'll give us some samples so we as teachers can help you guys prepare. And again, it's 45 minutes. So normally the free response section, you have an hour and a half, and there's 7 questions total, 3 long at 20 minutes each, and then 4 short at 7 to 10 minutes each. So it just says they will measure skills that can't be learned from Google or chats with friends. His words, and Mrs. G's laughing. Okay, so I repeat. I think I need to repeat that. The at-home AP exams this year will not include any multiple choice questions, only free response questions adapted for secure testing at home. They will measure skills that can't be learned from Google or chats with friends. I can't keep a straight face. By April 3rd, we will post the specifics for each exam. So, traditional in-person testing is gone this year. Again, don't hold me to that. College Board is notorious for going back and changing their minds. But as of today, the plan is to get rid of, for this school year, in-person exams. Beginning on Wednesday, March 25th, you can attend free live AP review courses delivered by AP teachers across the country. Optional, mobile friendly, available on demand. focus on reviewing the skills and concepts for the first 75% of the course, and we'll also have some supplementary lessons covering the final 25% of the course. So I think that's one way that they can kind of cover their butts a little bit and review some material in case we go in a different order than the rest of the country. For AP Chem, this is for the review sessions, not the exam date. So starting next Wednesday, they're going to go over everything we've been talking about kind of the past 2 units, which is nice. So Unit 8, so this is what College Board calls Unit 8. That's acids and bases. That covers everything from Intro to Acids and Bases, Ka, Kb, pH, pKa, titrations, buffers, and Ksp. So they'll kind of start reviewing the unit we're currently talking about next Wednesday. And that's about all the updates I have right now. I'm going to open the floor to questions. Text me on Remind, type in the chat. And then I will start reviewing the current unit in its entirety. Oh, here's some other things they've said. The at-home exams are designed and administered in ways that prevent cheating. We use a range of tools and techniques, including plagiarism detection software, to protect exam secure integrity. Scoring at-home AP exam work is not new. For years, we've done this for CSP, which I don't know what that is, and AP Capstone. Thank you. That's computer science principles. Again, specific AP exam dates and free response question types will be posted by April 3rd. They will start unlocking any relevant FRQs in AP Classroom for us to use digitally so we can practice in advance. In terms of, as far as I can tell, if you decide, they release information about getting a refund. And that information is you're not getting one. So if you've paid for it, you're signed up to take it. You're just taking the new one. I think that's about it. So questions. That's the state of what's happening. Very true. Can't do anything about that. Feel free to contact College Board. Any other questions about AP exam? That I can answer. I like I said, I'm going to do my best to answer, but I'm not going to have all the answers for you. I'm going to guess yes. So, unfortunately, the AP exam is an international test, and we have states in this country right now that have canceled school for the remainder of the year. Some states are out until May. I think Kansas just said we're done. So they had to make the decision with all of that in mind. So if we were to go back to school, the test is still going to be online. Anything else about the AP exam changes? It's been a fun week. It's been a fun week. All AP tests. I don't know. I don't know if we would offer the online test in school. That's a good question. But yeah, all AP tests are completely revamped this year. Not just AP Chem. Now, there's some specific ones that probably don't concern us, like AP Studio Art and stuff like that. Those have specific things that they need to worry about. So they've released more specific details for the art classes and computer science principles, but and then AP Research, AP Seminar, and that's it. Every other course is a 45-minute FRQ only. So this is not just affecting AP Chem, this is affecting everybody in an AP class. But Doggo, that was a good question. I don't know. I don't even know how College Board's going to handle making this available. Like, is it a specific time? Can you access it at any time? I would guess that they have to say you need to sign on at 3 p.m. And if you miss it, you miss it. Or else your friend can take it, 20 minutes before you and then just tell you what was on it. So I would guess that College Board will think through that issue and say, all right, everyone, here's the time we're offering AP blank. Here's the time we're offering AP Calc. Here's the time and date we're offering AP Chem, etc. If you missed the test, I guess you missed the test. If you were to miss the actual AP test, then you would miss the actual AP test. So, I don't know. I guess you would just be out of luck. Can't answer that question. Specifically referring to Doggo's most recent question. I cannot answer you. But Maddie, if you miss it, you miss it. A lot of these questions, I'm not going to contact College Board on behalf of you guys. I think you'll have a more powerful voice if you contact them yourself. So if you think of anything in the meantime, it's stuff like this when they make the info public and they get a lot of feedback, and then they can kind of backtrack and say, okay, maybe we didn't think this through entirely, and they can make changes. It's happened before. Public pressure works. So let them know what you think and your thoughts, and let your parents know about this change and have them contact as well, because if I had to guess, most of your parents paid for these tests. So, but in terms of specifics, I have no idea. Don't know. That question was raised, Sarah, immediately. Like on Twitter. Not even taking the test together, what's stopping people from just having like a chemistry professor as a father, or just a chemistry professor who's a father or mother's friend, or just going to Skidmore and just taking it at Skidmore with a chem professor? I have no idea. They insist they have ways to prevent cheating, so I guess they will find ways to prevent cheating. But that was a question raised almost immediately. Is how will you ever know 100% that this was fair? And I can't answer that question. Anything else about changes? I don't know if they're gonna make you have a camera. Yeah, I have no idea. I do know that you can't just assume that a computer automatically comes with a webcam, but I don't know. Also, just how it's worded, it's very strange. Like, they're saying it's stuff you can't Google type free response questions, so I really don't know. I'm hopeful they give us some samples so we can like get a good idea of what's the test is going to look like. Any other questions going once? And then I'm going to move on to reviewing this current unit. Alrighty. Buffers and KSP. So, just a general confusion about this unit in general. Probably because we were in the middle of it when this crisis started occurring, and then we hit daylight savings, had an earthquake, and then we're home from school for a month and a half. So this unit's been a little messy, to say the least. But we're going to just kind of take it from the top, and obviously I'm not going to like go through all the firm details, but just give you like a general overview of what's been happening because it's been a little confusing. So, buffers, we need to unpack what that is. They're a solution made to resist changes in pH. And how they resist changes in pH is all about what you need to do to make them. So to make a buffer, you need a weak acid and a weak base. So you can pair up a weak acid with its conjugate base. You can pair up a weak base with its conjugate acid. Or you can take a strong acid or base and partially neutralize it, which we'll see in a minute when we talk about titrations. We'll go over what partially neutralizes means. But, so weak acids, conjugate base, you can get these again from a salt, the conjugates that is. You can get those from a salt, or you can get them from partial neutralization, and I'll go over both. Partial neutralization, that's what that says. So, what does that mean? Let's unpack that. So, if you have a weak acid, let's say you have acetic acid, has a Ka of like 1.8 times 10 to the negative fifth. Let's rewrite that. 1.8 times 10 to the negative fifth. Oh my God, Mr. G. Ready? 5. If you want to make a buffer with acetic acid, you can dissolve acetic acid and a salt that contains its conjugate base. So something like sodium acetate, because that contains the acetate ion, which is the conjugate base of acetic acid. So when you dissolve acetic acid on its own in solution, it'll hit equilibrium, H+, and then you have this ion called the acetate ion, which needs to gain an H back, which is what bases do, to become acetic acid again. So if you have a mixture of an acid with its conjugate base, you are making a buffer, because since you have both of these substances lying in solution, if you were to add base into that mixture, the base would react with the acetic acid, by plucking an H away from it. So we're going to neutralize it. So we have the acetate ion being formed and water. So notice you're not forming a substance that's going to result in a big pH change. All you're doing is forming an ion and water. So that's what happens when you add a base to a buffer. The base will react with the acid or the conjugate acid, depending on what the type of buffer was. So if you go back up to the top, if you have a weak acid conjugate base buffer and you add a base, any base, sodium hydroxide, it'll react with the weak acid. If you have a weak base conjugate acid buffer and you add a base, it's going to react with the conjugate acid. Doesn't matter if the acid's strong or weak, neutralization is neutralization. This will occur, the base and the acid will react, and you will get water, and in this case, the acetate ion floating around. Really, because like Na plus is floating around here and Na plus is floating around there, you make sodium acetate and you dissolved sodium hydroxide, but sodium is ultimately going to be a spectator. We're concerned with that plus that makes water. Okay? The reason the acetate ion is not a spectator is because acetic acid's a weak acid, so it is not splitting up on the left side. So the net ionic equation includes the acetate ion. If you were to add acid to that solution, then it would react with the acetate ion to reform acetic acid. So that is why buffers resist pH changes up to a certain point. You add a base, it reacts with the acid in solution. You add an acid, it reacts with the base in solution. That's how buffers work. Now, in terms of the buffer capacity, which is just talking about how well does a buffer work, that's all about moles. So if you dissolve 100 mils of acetic acid, we'll just keep the acetic acid train going, 1.0 molar, and you dissolve 300 mils of 1.0 molar sodium acetate, you would predict that this buffer that you have created would be better at resisting the change when you add an acid into its solution. A base will still get neutralized, but not as well. Why? Why would adding an acid to this solution do a better job? Because you have a whole lot more of the acetate ion floating around, which is the conjugate base of acetic acid, that will react with any acid you put in solution, let's say HCl, and it will do a better job at resisting that change of an acid because you have more moles of it. If you do 1 times 0.3, you have 0.3 moles of acetate ion and only 0.1 moles of acetic acid. So this buffer will work until you've completely run out of either ingredient. Once you've run out of acetic acid, once that 0.1 moles is gone, you add a drop of more base, boom, pH is going to sharply rise up. So that's what will lead us into the discussion about titrations. But first, I just want to knock out everything about buffers in advance. Buffer capacity is just all about how well does a buffer resist pH changes. That just depends on how much acid and conjugate base or base and conjugate acid you've used to make that buffer. The more you've used, the better it will resist those changes. In this case, the buffer that I just made up would do a better job at resisting an acid because I have more moles of conjugate base in my solution to react with acid compared to moles of acid in solution to react with any base I would add. There's been a little confusion about partial neutralization. What does that mean? How do you make a buffer via partial neutralization? Well, if you were to react, let's say 100 mils of 1.0 molar. I'm just going to use acetic acid just to keep that train going. And instead of dissolving a salt containing its conjugate base, you can dissolve a straight up base. So if I dissolve 100 mils of 0.1 molar NaOH, I'm not going to do the math to save time, but it should be clear that my acetic acid is in excess. Right? 1 molar at 100 mils versus 0.1 molar at 100 mils. So this base and this acid will neutralize each other because that's what they do. And neutralization reactions always go to completion. And there you create the salt that you could have added to begin with. You create sodium acetate. So instead of just mixing an acid and a salt that contains its conjugate, or instead of just mixing a base and a salt that contains its conjugate, you can take a weak acid or a strong acid, it doesn't matter, and have that be in excess and then partially neutralize it with sodium hydroxide or any other base, and you will make the salt that contains the conjugate in solution. So instead of just mixing the acid and the conjugate straight up, you could just have excess acid, react it with a little bit of base, and then boom, you've created the salt that contains its conjugate. That leads us straight into what's happening in a titration. That is why during a titration, not the best curve, but that's fine. This beginning part minus the first half, this beginning part, again, I'm trying not to highlight the y-axis, that's all, is why that's called the buffer zone. Because I'm going to flip it now. I'm going to add an acid to a weak base. Or, you know what, let's do I'll add an acid to a weak base. So this is milliliters of HCl added. So that's called the buffer zone because we have, let's just say, a beaker. You wouldn't normally use a beaker, but that's fine. And this time we have a weak base in it, NH3. And it's 100 mils of it at 1.0 molar. And you're adding in HCl. When you're doing this titration, you're doing it like drop-wise. So I'm adding like a drop at a time. Or let's pretend just like a milliliter at a time. And you're adding 1.0 molar HCl, but 1 mil at a time. So it's going really slowly. So initially, in the solution, initially what's going to happen is it's going to partially neutralize that base. So the NH3 will react with the HCl to form NH4 plus and Cl minus. So instead of the base totally disappearing, we have what? 0.1 moles of base, and you're basically adding, so you're adding 1 mil at a time. You're adding like 0.001 moles of acid at a time. This disappears. This decreases a little bit to become that. And now you have a mixture of in this case, a base and its conjugate acid, and that creates a buffer. So that's why, as you're adding that acid slowly, initially, the pH only goes up like a little bit at a time before it shoots up. So that's why that's called the buffer zone. When you're making a buffer, and it only applies to the buffer zone on a titration, and if the problem just straight up tells you have a buffer, that's when you use the pH equals pKa plus the log of the conjugate base over the acid. So, initially, you are nothing. So let's go back to acetic acid. initially, you're just 100 mils of 1.0 molar acetic acid. So right at the beginning of the graph, right here, you don't use the buffer equation because you have not dissolved any conjugate base into solution yet. You just have a beaker with acetic acid in it. This is the very beginning of the titration. This is at 0 milliliters of anything added. So you don't use that pH equals pKa equation because you've not added anything yet. You're just an acid hanging out in solution. Then, as you add a drop of base, now you'll have a mixture of the acid and the conjugate base. Now you can use this equation because now you've created some conjugate base. How do you figure out how much you've created? You just got to do a little bit of stoich and do some mole ratios, and 99% of the time they're in a 1:1:1 ratio. So you just have to figure out the new total volume, new total V, how much reacted. So if you had 100 mils of 1 molar H2CH, wrong formula, of HC2H3O2, and you added 10 mils of 1 molar NaOH, that's when we started doing like the before change after tables, because we're not worried about equilibrium right here. We're worried about this is going to neutralize, because neutralization reactions always go forward, and that means we need to stoich. So you have 0.1 moles of your acid, you have 0.01 moles of your base. That's clearly my limiting reactant. I'm going to make 0.01 moles of product while having 0.09 moles of acid left over. Okay? Because they are partially neutralizing each other, because I only added 10 mils of base. Now you get the molarities again. So it's not 100 mils anymore, it's 110. So your acid molarity would be 0.09 divided by 0.110 liters. And your base molarity would be 0.01 moles. This is your conjugate base, divided by 0.11 liters. Plug it into the Henderson-Hasselbalch equation. Do the log of the conjugate base over your acid plus the pKa. That gives you the pH. At the half equivalence point, you don't need to derive this. It's easy peasy. The pH equals the pKa, because if you add 100 mils of, I don't know what the equivalence point of this is going to be, but at the equivalence point, when you look at that equation, where'd it go? The conjugate base and the acid are going to be at the same concentration. You're going to do the log of 1. You're going to get 0. You're doing pKa plus 0. So if you're given a Ka, remember to get pKa, so to go from Ka to pKa, you just do the negative log of Ka. Because the negative log of anything is just px. That's how you get pH. That's how you get POH, the negative log of H, pH, the negative log of OH, POH, etc. Okay. So when you're at the half equivalence point, the pH equals the pKa. You move on. When you get to the equivalence point, what does that mean? That means that the moles of your acid equal the moles of your base. That does not mean the pH equals 7. The pH only equals 7 when you've perfectly neutralized, that's why the moles are the same, a strong acid with a strong base. So in our example with acetic acid, when you add 100 mils of 1 molar base to 100 mils of 1 molar acid, those moles are the same. 0.1 times 1 equals 0.1 times 1. That's the equivalence point. That does not mean it'll be a pH of 7 because it's a weak acid. So it's not dissociating completely, so you're not forming a neutral salt. In this case, you're forming a basic salt. So the equivalence point is defined as moles of acid equal moles of base. It is not defined as having a pH of 7. If you're titrating a weak acid with a strong base, the pH at the equivalence point will be above 7. If you're titrating a strong acid with a weak base, the pH at the equivalence point would be below 7. Because again, you created a salt that is not neutral. In this case, you have an acidic salt. In this case, you'll have a basic salt. You also need to keep in mind what's happening at a particle level, and I've done not so great of a job of that, and I apologize. So initially, you have an acid in solution. So we have a bunch of hydrogen ions floating around. Not a lot because it's a weak acid, and I'm not drawing this to perfect stoic ratios, but you have an acid initially in solution. In our example, we're using acetic acid, so we were titrating acetic acid with NaOH. So initially, I have hydrogen ions floating around. At the half equivalence, I have half the hydrogen ions floating around, because in this case, we had 100 mils of 1.0 molar acid, and I've added 50 mils of 1.0 molar base. I'm not going to have any hydroxide ions floating around because they've reacted with some of the acid, which is why my hydrogen ion concentration has taken a dip. But my acid is still in excess, so I have some hydrogen ions floating around. And we're picturing this with the people we care about, and the people we care about, the acid and the base. There's obviously like salt ions floating around, etc. But I'm showing you a diagram of what's happening to the acid. At the equivalence point, we've 100% neutralized it. Which means we don't have any hydrogen ions floating around. We don't have any hydroxide ions floating around. We're just going to have some Na plus ions and some acetate ions, because all we have in solution is our salt, which in this case is sodium acetate, and water. The water part has given us some confusion on the AP classroom, because some of you are like, doesn't water auto ionize in solution? And you're right. So water can split in solution. This is how we get Kw. But the value for Kw is 1 times 10 to the negative 14th, which means the value of each of these ions is 1 times 10 to the negative 7, and that is insanely tiny. So be careful of how the question is worded. I don't think they can hear it.
Yeah,
the link didn't go through.
Oh, the link is coming.
Oh, okay. There's only 3 people watching right now.
Go listen to Hall Notes.
Once I started talking about AP Chem, they were like, learn? No. See ya. So the question on AP Classroom, I'll just be very honest, was like, it was a multiple choice question. It was like, what ion would be in solution at a concentration of 0.01 molar or higher? And a lot of you were including the hydrogen hydroxide, and we were at the equivalence point. And I understand why you would say hydrogen hydroxide in there, because water can self-ionize, and I get it. It does do this. However, it said like at a decently high concentration, and 1 times 10 to the negative 7th is not that high. The only thing that'll be in solution at a decently high concentration is the salt ions. And in this case, it would be sodium acetate. You get 1 drop past equivalence. I don't care if you're a drop or 1,000 milliliters. Your base, in this example, because we did a weak acid and a strong base titration, your base is in excess. Now you will have hydroxide ions floating around in the water. So this was kind of like a big overview of buffers and titrations. I encourage you, if you're working on this at home, just text me with questions, please. I would love to go over it with you at this point. The last thing we did was KSP. And again, I'm trying to do a lot of this review off the top of my head, so if I miss anything, I apologize. KSP, so the background of it. Things that are insoluble are not like 100% insoluble. They split a little bit. They just have such tiny Ks that to our eyes, it basically looks like I add it in the water and none of it splits. So silver chloride is a big example. It splits into silver and chloride ions, but the KSP for this is like 1.8 times 10 to the negative 10. So if you do the square root of that, because silver chloride is a solid, so you remember we don't include solids in our K expressions. So the K for this would be equivalent to the silver ions plus the chloride ions. These numbers are going to be really small. They're going to be like 1 point something times 10 to the negative 5 for both of them, because they're in a 1-to-1 ratio. So that's why to the naked eye, it looks like silver chloride is completely insoluble in solution, but really it splits a little bit. It just doesn't split a lot. So that's what the KSP is telling you. KSP is giving you an idea of how well a salt or weak base or any real weak electrolyte is dissolving in solution. And sometimes it dissolves a lot, and sometimes it dissolves a little. I encourage you to watch the video on one of my last streams where I really go into KSP significantly. Actually, let me bring up the problems there because I don't want to make this up again. Okay, so here we go. So, let me just have that ready. So one of the big things it's going to ask you about is what's the molar solubility of AgCl? All that is just basically asking you for the molarity. And that will be, in this case, equivalent to either ion because they're all in 1-to-1-to-1 ratios. So you can do it for either ion and you will get the molar solubility for AgCl because the molar solubility at the end of the day is basically just what's the molarity? If you have an example where it splits into 2 of a certain ion, so in this case PbCl2 splits into 1 lead ion and 2 chloride, you can still do it in terms of just the lead ion because these are in a 1-to-1 ratio. And then if you're trying to calculate the molar solubility of PbCl2, you just need to get the molarity of the lead ion, and then you're done. You could get the molarity of the chloride ion, but then you'd have to remember to divide by 2 at the end because they are in a 2-to-1 ratio. So, another thing you need to be able to do is predict if a precipitate's going to occur, and that's when you need to compare Q versus K, and I'll unpack that right now. If Q is greater than K, you will end up having a precipitate. So to review about what Q means, all Q means is it's calculated the same exact way as K. It's the constant that's not at equilibrium. So K is calculated at equilibrium, but Q you can calculate at any condition that's not equilibrium. So think about like those initial conditions that you can calculate Q for. Or if you mix some things together randomly, now you can calculate Q. And if Q is greater than K, it precipitates. If it's less than K, that means it is unsaturated, which means I can dissolve more of this substance before it starts to precipitate. And if Q equals K, that means you've dissolved the exact amount of substance to make it perfectly saturated. So if you add even a drop more, it's not soluble. So we did an example the other night where we had lead chloride dissolving in water. It has this K value, and then we added to it 2 salts that contain the ions in that formula. So we added lead nitrate and we added sodium chloride. So what we need to do now is figure out how many moles of lead and chlorine we've added to this solution, and therefore see how the common ion effect works. So we figure out the moles first, and the reason we do that is we're going to have to calculate new molarities of these ions because we are combining their volumes here. We're combining 150 mils and 100 mils, so our total volume has changed. So I get the moles of my lead ions, I get the moles of my chlorine ions, I reconvert them back to molarity because I need molarity in my K expression. It's all about concentration. And then I plug it into Q, see that Q is 3.8 times 10 to the negative fourth, compare it to my K, which is 1.2 times 10 to the negative fifth, see that Q is greater than K, which means if I were to mix these 2 salts together, the PB and the Cl would eventually combine, and since the Q is greater than the K, it would precipitate. So when you mix the salts together, you have PbNO3 plus NaCl, you're going to get a double replacement reaction, which means the lead is going to bond to the chloride and the sodium is going to bond to the nitrate. And we're just trying to figure out, when you mix these 2 salts together, are you actually going to get a precipitate, or would this remain dissolved? And you can't just say it's going to precipitate because lead chloride is insoluble, because remember, it's insoluble kind of to the naked eye, but it splits a little bit. So we just calculate a new Q, get 3.8 times 10 to the negative 4 at these conditions, compare it to the Ksp for lead chloride, see that it's greater, so I can safely say that yes, this would form a solid. However, if the conditions were a little different, maybe if this was like 0.001 and 0.002, maybe a precipitate would not form because we're not dissolving enough moles to cause a precipitate. Maybe in that instance, the Q would be less than K and therefore unsaturated. The only other thing that kind of pops up with Ksp is like the common ion effect. So if you were silver chloride again, if you were to add HCl into this, the solubility of silver chloride would go down because HCl has chloride ions in its formula. So the chloride ions in solution is increasing, and that's going to shift this reaction to the left by Le Chatelier's principle, causing more silver chloride to remain as a solid instead of splitting, and then therefore the solubility goes down. Just be careful. They don't have to say like add HCl. They could give you a scenario with a base, like a weak electrolyte with hydroxide. So like MgOH2. MgOH2 is a weak electrolyte. It is not one of the strong bases. Remember, the strong bases in group 2 start at calcium. So instead of saying you add this, it could say, what would happen if you added a substance that increases the pH? So now you have to think, okay, increases the pH. That means I've added a base. And if I've added a base, that means I've added hydroxide ions into the solution. That moves up in concentration. This shifts to the left to counteract that change. And that substance becomes less soluble. All right. Anywho, obviously a lot of crazy news today. I wish I had more answers than I do. But I'm going to head out. Guys, enjoy your Friday. I hope you have a good rest of your day. And I'll talk to you guys over the weekend.